Okay, this is the second part of the video, and I wanted you to know that I lied to you earlier. For those of you that watched the videos, hopefully everyone did. I lied to you in the first video because this is not Riemann sums. That's something we're going to do later on. We are doing limit summations here. The reason I hesitate is because we may not actually do limits so much. We're really just doing summations. We're focusing on what a summation actually is. So let's go to page 5. And let's try these problems. You will need a calculator out if you don't already have one. And we're going to use those formulas that we had before. And I'll write them down here at the top just so you don't have to keep flipping back and forth. The sum from I equals 1 to n of c is equal to c times n. The sum from I equals 1 to n of I is equal to n times n plus 1 over 2. And I think we'll see the last one, the I squared one, I'll write down here. The sum from I equals 1 to n of I squared was equal to n times n plus 1 times 2n plus 1 over 6. Okay, let's see what we get here. Again, purely formulaic. I could write out this 3 plus 3 plus 3 plus etc. from I equals 1 to I equals 2 to I equals etc. Too long. If you did it, I'm sorry. Just way too long. Way too long. N is 10. N is that top number. So if n is 10, let's just plug it into this formula here. So we have 3, C is 3. 3 times 10 is 30. Easy peasy. Next. Here, n is 10 again. Now when n is 10 here, again, I could write out 1 plus 2 plus 3 plus 4 plus 5 and make a rectangle to see how it works. Or, knowing that n is 10, I could actually use the red formula, and I can do 10 times 10 plus 1 over 2, which is equal to 55. 10 times 11 over 2 is 55. One thing about multiplying those, many students like to multiply the 10 times 11 first and find half of 110. I like to divide the 10 and the 2 to be 1 and 5 to get 55. I do not need to rubber band this because I do not have two terms in the numerator. I only have one term. A little calculation note there. For 3, and now I'm zipping along because these should be pretty quick problems. Here, again, I could list out 1 squared plus 2 squared plus 3 squared plus 4 squared. I've added up all those numbers if I want to. Or, knowing that n is 10, I could just plug them into the formula. So n is 10 means that I'm going to have 10. Just make sure you're clear. I'm going to have 10 times, and then we're going to have 10 plus 1. Now let's do that in a different color. 10 plus 1, which is 11, times, and then 2 times 10 plus 1. So 2 times 10 plus 1, which is 21, all divided by 6. In your calculator, you're welcome to do 21 times 11 times 10 and divide by 6. But again, there are patterns in the numbers here. I could take 21 and 6 and divide that at 3 out of each one to get a 7 and a 2 here. But then I could also take out a 2 out of the 10 and the 2 to leave a 1 on the bottom and a 5 here. So now I'm doing 35 times 11. And if you want to know some more number tricks, I'll show you. 35 times 11 is the same thing as doing, let's see if I can explain this right. Put the 5 down, add the 3 and the 5 to get 8, and put the 3 down. So your answer should be 385. When you add up all those numbers, 1 squared plus 2 squared plus 3 squared, hi squirrel. When you add up all those numbers, there's a squirrel outside, you're going to get 385. Okay, so now we have a huge sum. And this is just, the purpose of this problem is to show you that you can actually break up summations, which is kind of assumed and kind of what you can do with limits and derivatives. You can actually break this problem up as a sum from I equals 1 to 10 of I squared, plus the sum of I equals 1 to 10 of I, plus the sum of I equals 1 to 10 of 3. And since we have all three numbers, let's put them in here. The first one was 385 from number 3. The second one was 55. So let's get 55 here. Yep, that was a blue one. 55. And then let's get the third one. I believe the third one was 30. And we can add these all up, and I believe we get 470, 480. Let's check, make sure that I can do it. Believe it or not, Desmos can actually do this as well. I can show you your calculator. Your calculator can do these as well, in the sense that your calculator can actually put in these sigma notations. I'll show you that in class, although it's not entirely relevant for our course because you will never get many problems like that in this class. Let's go on and do this here. Let's do sum. I'm going to change this variable to I equals 1 to 10 of, let's see, what do we say? I squared plus I plus 3. 470. Let's see. I thought it was 470 originally. Oh, yeah, it's 470. It's 470. Oh, Mr. Lee, I want an extra credit point. I was saying that the whole time. Nope, didn't hear you. Okay, 470. Oh, look at this, number 5. I love number 5. The reason I love it is because there's a 2 multiplying the summation. There's a 2 on the outside of this whole part that's being multiplied. So we could just take this 2 out of the summation and keep everything else inside the summation. And because we are multiplying that sum, we can take the 2 out and multiply it times this part, and that part was equal to 470. So now we just need twice 470, which I believe is 940. A good thing to review here is when can you not take something out? So when are you not allowed to take something out of summation? You cannot take a number out of a summation if the number depends on I. I'm just going to pause there and let that absorb. You cannot take something out of a summation and put it in front of the sigma if that number is dependent on I. And what I mean by that, this I squared depends on I. I have to leave it inside the summation. This I depends on I, and I have to leave it in the summation. This 3 depends on the index, because I'm saying to add 3, 1 times, 2 times, 3 times, 4 times. But this 2, well, that ain't doing nothing. That's just saying take 2 times your sum. So I can take that 2 out. So in fact, I could just take care of number 6 in 2 ways. The 1 over n is not dependent on I in any way. There's no I associated to it at all. So I could rewrite the summation as 1 over n times the sum from I equals 1 to 10 of I squared plus I plus 3. Why is this doing this to me? Oh, that rhymes. Mr. Lakin, your handwriting is getting so much worse. True. And here, we could also write this way and leave the 1 over n inside. And you'll see that we'll actually be doing that in the later problems for a very particular reason. A very, very, very particular reason. Doesn't matter where you put that 1 over n, on the inside, on the outside, it's fine. Either way, we already got the summation. I believe that was 470. So we have 470 times 1 over n, which is equal to 470 over n. Dunzos. Next. Okay. Here we go. We're going to do this for, we're going to deal with this sum from I equals 1 to n of I plus 1 over n squared. We're going to plug in values for n and see what happens. Holy moly, that's a big number. That is a massive number. Okay, that's neither here nor there. Notice that we're taking this I plus 1, adding I and 1 together in the summation, and we're dividing it by n squared, which means that I could rewrite this as the sum from I equals 1 to n of the summation of I plus 1 times 1 over n squared. Sorry, there was a hair on the computer screen. It was bothering me. We could actually rewrite this now because we know what the sum of I is. Remember, we said that the sum of I equals 1 to n of I is equal to n times n plus 1 over, go on, say it, Mr. Powerade. Good, 2. Okay, and then we also said that the summation from I equals 1 to n of just 1, or some constant, will just be equal to that constant times however many terms we have, which is n. So we can rewrite this part as the summation of I, we said was n times n plus 1 over 2. I messed up the colors. Mr. Lakin. 2 plus, and then we have another n here. The 1 is an n here. And then we're multiplying this all times 1 over n squared. And that's going to be n times n plus 1 over 2n squared plus 1 over n. Aha! Now we could simplify that. That's going to be an n plus 1 over 2n plus 1 over n. Now we could simplify that even more if we want to get a common denominator. And we could get n plus 1 plus 2 all over divided by 2n. And we could simplify that more as n plus 3 over 2n. And I really hope I didn't make a mistake. Let me pause to check my work. Yep, that looks good. Okay, so now let's see what happens here. Oh, I see what Ms. Schwartz did. Did you guys see this? She did a pun, summary. Okay. Since we're not doing this in class, let's do this on Desmos. We're going to find all those values here. Let's see here. Let's go on and do I plus 1 times 1 over n squared. Let's put an n here. Let's go and do that. I'm going to type another one and just make sure that I have the formula right. I'm going to do n plus 3 over 2n just to make sure that I get these same numbers, because if I don't, that's going to be a problem. And let's go ahead and make a table of these values. How do I make a table? How do I make a table? Oh, I know how. Okay, let's do this. Let's go and do this. Let's go and do this. Doink and doink. Okay, let's go and do this. Doink. Okay. And okay, no, it doesn't like that. Let's just call it x. Let's call it x. Okay. And I'm going to move this here. Hold on just a second here. Okay. And we'll just delete that. Perfect. All right, when n equals 1, we get 2. So you should be writing this then. When n equals 1, we get 2. When n equals, what do we need next? 10? I think we need 10, 100, and 1,000. When n equals 10, let's see what we get. We get 0.65. 0.65. 0.65. Okay. When n equals 100, we get 0.515. 100. 5. Okay, cool. We get n equals 1,000, add a 0. We get 0.5015. Ooh, something's happening. 5015. And it has 4 zeros. 4 zeros. Add another 0. Ooh, hello. We get 0.50015. Uh-oh. Messed up. 1, 2, 3, 4. 0, what was it? 015? Yes, sir. And let's do another 0, another 0. Okay, so we can see that we're just, the zeros are adding on here to in between the 5 and the 15. So you can write those in. Let's finish up in 15 minutes here. What would happen if n keeps growing, say, infinitely? So the question is asking is if we have the limit as n goes to infinity of I equals 1 to n of I plus 1 over n, what do we think that equals? Because we could take a limit of a summation. That's kind of where we're going with this. When n gets huge, really big, it looks like we're going to get 1/2. Now, how did I know that? Because the limit as n goes to an infinity of our reduced version of n plus 3 over 2n, well, that's not top heavy or bottom heavy, so take the ratio of 1 over 2, and you get 1/2. And that's kind of what we're going to be doing the next time in class on Monday. Thanks for watching both videos.